Alright. I'm going to do a lecture today on procedural 3D, and I'm going to do it with Houdini, because that's what I'm familiar with. But the first question, which is probably on a lot of minds right now, is what the hell is procedural 3D? And that's a fair question. It's pretty new, and it's pretty different from the 3D that you probably know. 3D models are typically modeled by hand, right? So you would put down point and put down faces, extrude stuff, etc., etc. But there are other ways to do things that are lesser known, but are beginning to get some traction in some fields. And one of them is procedural modeling. And that implies that rather than having a set of actions that you do, like extrude something, etc., etc., you act as a series of operations. You're not doing a model, you're creating a procedure that will create a model. And that might be a bit confusing at first, but if you've ever used Substance Designer, you're actually a bit familiar with the concept. Essentially, procedural 3D is to Blender what Substance Designer is to Photoshop. So we are in Substance Designer, and what we have here is a series of operations, presented here as those nodes, that are done on those images, represented here, right? So here I have an image of some sort of clouds, and maybe I want to darken it a bit, right? Or maybe I want to know that Pempelune is taking the eye frequency out of it, right? So that's something that you could probably do in Photoshop. I don't know, I don't use Photoshop, but I think you can do that in Photoshop. So in Photoshop, you could have that act of creating, of taking all the eye frequencies and making it into another texture, right? And maybe afterwards, you also take to scan out some frequencies, and maybe something you want to color it all in blue, or shift it all into merging different images. So all those actions, you can probably do them in Substance Designer, but the difference is that whereas in Photoshop, once the action is done, it is done. In Substance Designer, what you're doing is you're putting out a node. You're putting down a node, and that will be doing the transformation for you. So what you're not directly building the texture. You're building a procedure made up of operations, right? And each of those operations is represented here. So whereas in Photoshop you would have a history, right? So you can actually, you have a list of actions, and if you're not happy with something you've done, you can always go back, right? But you will have lost everything that you've done since. This is not the case here. So that answers what is procedural modeling, right? It's a series of operations, and all the operations here are presented as nodes. And of course, you have parameters that you can apply. So here, for example, if I want to select different frequencies, I can act on the position and select different frequencies, and I will have an effect on the final texture. But then why would you want to do that? Because that looks a lot more complicated than traditional texture making or 3D design. And you would be right most of the time. Sorry, Liz? Okay, so here we have our texture. Sorry. Okay, so why would you design like that, right? It's not as easy. And you would be right to think that most of the time, modeling something procedurally is more complicated and less intuitive than with traditional techniques. Because say here, right, maybe I want to color specifically those parts as different colors, right? Maybe I want this style to be a different color than this style. But actually, how do I tell the computer that I want to select this style and not this one? Right? There is actually no simple way to do that in Substance Designer, for instance. In Photoshop, what I could just do is like take the pen tool and select the area that I want. But in a Substance Designer, that is very difficult to do, and you will need to find a procedure that allows you to select a specific part of your texture. You can't just paint something. So most of the time, and that is a big drawdown, a big problem with procedural modeling, is that it is not as intuitive as traditional tools. So that's something you will have to grapple with. And that also means that a lot of the time it will also not be as fast, right? Because you'll be constantly asking yourself, well, now I want to do this thing, but I don't know what, or how could I do it? So, of course, you could ask online. You could find tutorials. There are many. Also, not that many, actually. But most of the time, you'll actually have to research those things yourself. And that will eat a lot of time. So, then why would you do it? Well, it has a lot of advantages as well. As you've seen here, right? When I wanted to modify my texture, all I have to do is go into one of those nodes and change stuff. And I have immediately a noticeable impact on the texture, right? So what that means is that texture making like this is entirely non-destructive, right? You can do changes to your texture, to your 3D model or whatever, without losing what you have made, right? So that's very powerful. Because often a problem is that you want to change something that you've done at the very start of your creative process, and now you cannot, because doing that would mean losing a lot of work. Here, if I want to change a decision that I made at the very start, all I need to do is go here, right? And that will probably break some stuff, but it's fine. Yeah, it's not great, but I can do it, and maybe I'll need to do some fiddling, but the result is here, right? It worked. And that also allows me to generate a lot of textures or models from the same procedure, right? Because maybe if I want if I want to have more blues, I can do that. If I want those to be white, I can do that. If I want to use a different color scheme, that's very easy. So that means that with simple changes to the procedure and its parameters, I can create a whole host of textures of models with one procedure. So very little additional work required, which is obviously very powerful when you're trying to do a lot of stuff that are similar. Because that also means that if I want my palace to have a lot of nice mosaics, I can reuse that procedure to make all of them, just changing parameters as appropriate. And all those textures will look like, although they will be different, they will also look very similar. They will look cohesive. So that's a big advantage of procedural modeling that you will have over traditional methods. But that means that procedural modeling is just not something that you should use all the time, right? A lot of the times, it's simply easier and a better use of your time to go in Blender and do the stuff you want without worrying about making up a procedure for it, right? There are some cases where it's clear that procedural modeling would be easy and workable. Typically, you want to find cases where there are clear rules that define the geometry you're trying to model. A good example is a tree, right? A tree is easily recognizable because it has very clear stereotypes, right? So you start with a trunk, and then you have branches branching off, okay? And at the end of those branches, you get leaves. And you have a lot of parameters that you can play with, right? You can decide how many branches you're going to get. You can decide how many leaves will be on each branch. You can decide angles. But these are all parameters on a single procedure. So what you've got here is something that is easily made into a procedure that can generate a lot of models. And people that are familiar with speed tree here will probably know that speed tree itself, which is used a lot to make trees in the industry, and here in Beyond, here in Skyrim modding, speed tree itself is a procedural software, right? So trees are a good example where procedural techniques will be very useful, very efficient, because they will take care of all the fiddly bits for you and will allow you to model things more efficiently, more and quicker. Because you can actually easily see what the procedure is and how you have to create it, right? You have to create a trunk, you have to create leaves. And of course, in Skyrim, at least, it's preferable to use procedural modeling when many variants of a model will be needed. As I say many variants, what I mean is, if you're going to model one tree, right? If your whole mod needs only one tree, there is no point in making a procedure for it. You will be wasting your time. It will be much easier, probably, to go in Blender and do your tree, right? But if you're going to have 20 trees populating your landscape, then maybe making them all in Blender would be a waste of time, and instead you can make a procedure that's going to generate those 20 trees. So that applies to a lot of different things in Skyrim. Trees, rocks, because a lot of times you will need massive rock sets, and that can be very helpful to be able to generate them all procedurally. Architecture can be a good use of time as well. And tileset. So I haven't tried tileset before, but I think that's a very precise aspect, right? Everything needs to tile perfectly. I think that's something procedural generation would be very well suited for. Now let's see how you can design a procedure, and to get an idea what's a good procedure, I'm going to show you a game, right? That showed up on Steam a few years ago. It's called Townscaper. It's here, and well, it is a game, right? And the point of the game is to make towns, as the name implies. And the way to do that is just to click, right? I click here, and now I have a house. And maybe I can make another house not too far. Okay, that's cool. And but maybe I want to link them together. Oh, now we have a bridge house, very fancy. And but perhaps I'm not happy with just a bridge house. I also want a nice tower next to it. So I can click and keep clicking, and now I have a nice tower. Very cool. And all I have done to create this is a few clicks. So of course that's a very nice game, but let's think of it not as a game, but as a 3D software. Okay, this is a 3D software that creates towns, and the way it does it is smart, because in a few clicks I can generate very complex shapes. That's looking a bit fancy. I can create very complex shape. Okay, I can make maybe a walled garden. That would be cool. Okay. Okay, now I have a garden. So this is all, of course, procedural. Notice how the shape of the tiles is uneven, and yet I can always make more models that fit it. Right? Look at this tower; it's weird. So this is all done procedurally, of course. And think about what it means for me as a designer of all those houses. What decisions I have and which have been taken from me, because I can design the overall look of the town, since I can make each building, and I can have an idea of, I can decide how each building will look. But what I cannot decide is lower end stuff, right? I does not get to choose where I put my windows. They have been put there automatically. And similarly, I certainly do not get to know to choose how I'm going to UV every house year, right? Those decisions have all been taken away from me. And this is actually necessary, because of course I could never be as fast if I had to decide on the placement of each individual window. So that had to be decided beforehand. One thing that you have to be very clear on when you're making a procedure is how much leeway, how much input are you going to allow to your end user, which often is going to be yourself. And here, and it is almost always a good decision, give only high-level decisions to your end user, right? Low-level decisions should, as much as possible, be handled procedurally, so as to save time. So yeah, that's the placement of windows. So that's a very cool application of 3D design, of course. Well, it's not really a 3D software, so, but I think it ought to give you a bit of some ideas about how to design a workable procedure. So now the question is, what software should you use? Of course, Townscaper is not a proper software, and of course, this is a Houdini class, so Houdini, right? That's a perfect choice. But there are actually other things you could do, other softwares you could use. For example, Blender, right? Surprisingly, perhaps, Blender has a pretty recent procedural system, which is called, I believe, geometry nodes, right? Here you have geometry nodes, and as you can see, it's like extrude, subdivide the surface, and what it allows you here is to make the classical donut, right? But in a procedural way, so that's fancy. Right, and as you can see, it only takes a few nodes. Well, still probably a bit more complicated than you are used to for the donut. But now you can make every donut, so that's nice. So as far as I know, I have not used Blender in that way before, but as far as I know, it's not yet as advanced as Houdini for procedural design. So I would recommend checking out Houdini instead. But it's getting better all the time, of course, as Blender is wont to. So one day maybe it will be actually as good as Houdini. So if you want to stick with Blender, by all means, check out geometry nodes and you'll be surprised at all the stuff you can do here. And you'll see that it's a lot of fun. But I cannot really teach that because I have not used Blender. So okay, so it's, as far as I know, it's mainly Houdini and Blender that allows you those capabilities right now. But surprise me. So now we are finally out of the introduction. And what is Houdini? So you've probably maybe you've heard of it before. It's mostly known for its VFX, right? It's a fantastic software for visual effects. So it's very used in the film industry, not so much in the game industry. And it actually does do a bit of traditional 3D in a sense. Like you could design models traditionally in Houdini. I would not recommend it. It's not nearly as good for that purpose as Blender would be, because of course it's not actually made for it, so it does not have all the tools. What it is good for though is procedural 3D. So of course that's what you should use it for. But let's check out the beast ourselves, right? So we have Houdini, and a nice thing that I forgot to mention about Houdini is that you have here Houdini Apprentice, right? So this is the free version that anyone can actually use without paying, which is nice. It's free. That gives you a lot of restriction on what you can do with it. But mostly for 3D modeling purposes, you can do everything, right? If you want to do VFX, you will probably want to buy the paying version, but that's not what we're here for. So do not be scared by Houdini because of the very hefty price tag. You do not actually need to pay in order to use it for procedural purposes. And so here is what it looks like. So we have, of course, the traditional screen, okay? And here you have the tab that will be used for parameters, and here you will have the tab that will be used to show the networks that you're building. So let's load something. Okay. It will take some time, probably. So as you can see, we are actually... Oh, there we go. That's not very pretty. Let's ignore that. But here you have, as you can see, the network, right? So it's a series of nodes, just as we saw in Substance Designer, a series of nodes that act upon geometry. So that's a big difference, of course. It's that we're not working with textures anymore. We're working with geometry, and that actually makes everything a lot more complicated. But it's really the same idea. So we start with a box. Okay, so I have put down here a node, which is the box node. And as you can see, we have a lot of different parameters we can switch here. Right, I can make the box smaller in the X direction, or I can change the uniform scale, and maybe I need more subdivision on this axis for some reason. And all that I can do. Okay, so that's great. And but maybe what I want to do is like expand it somehow. Maybe I want to make some sort of wedge shape. So how could I do that? Well, I'm going to use a transform. Right, so this transform node. What's going on here? No, shit. Sorry. Yeah, so I had changed the parameters and I did not make this perfectly. I apologize. Okay. Alright, so soft transform here, and as you can see, we have a nice effect on our geometry, right? Everything has been pinched off, and everything is controlled by those parameters here. Soft radius will determine how far our constriction apply, right? And of course, the final scale is decided here. Okay, so that's already a pretty powerful node that allows you to change your geometry in many interesting ways. But as you can see here, we're not actually acting on the entire geometry, right? We're acting primarily on this part here, okay? And then it actually happens to have effect on other parts of the geometry. But we're not, this node, take as entry a special group of nodes, right? It does not act on everything, and of course, that's very often the case. Oh, sorry, I actually missed a lot of things here. Yeah, something that we need to talk about is data organization in Houdini. Because since we're going to act procedurally, you need to know what you're working with. So you're working principally with geometry that will be made up of points and primitives. And primitives is Houdini's way to talk about faces. So if we go here, you can see every point, okay? And you can see the primitives between them. Each of those is a primitive. And of course, they all have their very own number, identifying them to the engine, okay? And what's interesting about that geometry is that it can hold data. Right? So that data is named an attribute of point or faces or whatever. And that can be a lot of things. And of course, one of the main thing that will come to mind is the position, right? Each point needs to have stored somewhere in the point its own position. And that is an attribute. That's a position attribute. And of course, there are a lot of others. You have normals, which can be either stored on the point or on the primitives, and which is, of course, a vector, right? A vector that indicates a direction. And you have UVs for coordinates. So all those, all that data is stored on the point and can be manipulated by acting on each point. And you can see actually the if we go here, right here, display group and attribute list, and we can actually see every attribute that we have on points or on primitives. So we're going to click on points. Okay, and these are the groups, but I want to see attributes, and here I can see px, right, the position, and I get to see the position, the x position of each point. So of course that's not very useful on its own. Also, of course, by manipulating the position, you can do all sorts of crazy things. But that's not it. That's not all of it. You can also store user-created attributes. And that means that you can remember things, right? Your data will store values that you can then use later. That will, of course, be very useful. So that was the first thing. And now, of course, as we've seen, it's often very useful to have a list of geometry that you are going to apply transformation only to them. And that's what we saw earlier, right? As you can see, this transform is applying itself only on this group, which is called the transform group, and which is defined here. Right? So there are a lot of ways you can define groups. And here I have chosen a way which is the bounding box, right? So it's one of the simpler methods. And so I can change the center and change which points are affected. Very useful, of course. But there are a lot of other ways which are perhaps even more useful. Right? Perhaps you want to only include points that are exactly in the correct direction. Okay? Let's have a very loose rectangle. Okay. So now, as you can see, we have a direction, which is facing in that, well, what is it? Which axis? The z direction, yeah, that makes sense. This is the z-axis. And as you can see, all those points are immediately put into this group, because they are facing that direction from their normals. But I could actually trick the engine and change the direction of the normal and select points that are not actually facing in this direction at all. So we have a lot of flexibility here, and that's very important. Then there is include by edges, which is exactly what it sounds like, right? So you can select edges, and you can select what's inside, for example. So groups will be very useful because they will allow you to make transforms on only some parts, and that's something you're going to make use of every day. But as you can see, we have had a few mishaps, right? Because when I changed something here, right, I changed the size, and since my group here was defined through this bounding region stuff, as I changed the position of this cube, no points were inside the bounding box region afterwards. And that's of course a problem, because when you're making a procedure, you want one change, you want to see the consequence of one change, and you don't want that consequence to be everything is broken now. Right? So what you would want is that when I change a parameter here, this one here adapts, right? And that means that you need to adapt the parameters here as a function of those parameters here. So let me take an example, okay? So I have a rock. Where could I find a rock? Here. It's a bit time to... that's... okay. Here we have a rock, and maybe we want to make those edges a bit less pointy, right? But we don't want to actually... right, it's erosion. And we decide that erosion will only affect stuff that's very curvy, right? It will only attack stuff that's that has the highest curvature. So of course, what you want to do is immediately measure curvature, and as it happens, there is a node to do that. Called measure curvature. Oh, very useful. Okay, and now when I click on this node, you see that the high curvature areas are highlighted. And I can make it so that only the very high curvature areas will be highlighted. So okay. Now you can use a group to maybe blur out only those areas, right? So how will I blur out stuff? Well, position is an attribute, and there is actually a blur attribute node. Very useful. So I'm going to go in that attribute blur node, and I'm going to blur position here, which is called P. And right now I'm not seeing a lot of stuff, but if I make a lot of iterations, we're going to see a lot of results. Okay, it is all very smooth right now. But actually that's not what I wanted, because I only wanted to affect those high curvature areas. But how could I do that? Well, you have to have a group. So related to that idea of parameters changing, what I could do here is use what's called an HScript expression. Well, this is often what happens, right? You have no node that does exactly what you want. And one way to do that is to use HScript, which is going to allow you to control procedurally your parameters through a bit of code, admittedly, which can be a bit tricky. But here what I can do is I generated a parameter here called convexity, okay? And I call it, I want to make a group, okay, which look at convexity. So at convexity calls the attribute name convexity, and I want that group to be characterized by having a convexity greater than 1. Oh, look at that. Worked. I don't think it actually worked, but well. Now I have only applying this blur on objects that have a convexity that's greater than 1. So immediately you have a lot more flexibility, right? I'm coming back to our cube example. Okay. What I could do here for the soft transform is copy things, right? So I could take this parameter here, switch to copy parameter, and now go into soft transform, and put it into group, and put it here, right? Paste relative reference, and now as I change this parameter, it is also going to change this parameter because I am copying it. So that's one way. And this is also an HScript reference. So maybe actually I don't want to be exactly the same thing, I want to be time 10. Okay. And now every time I do a modification here, it's going to have also an effect on this node. Very nice. So just through that, you have also already made a huge jump in capabilities. You can already do, you can already have a lot more flexibility in what you do. But as you can see, you can already do a lot just with standard nodes. But sometimes you'll find that actually there is just no node that does exactly what you want. And even fiddling with the parameters is not enough. that's when we're going to use trickier stuff. Okay. And that trickier stuff is called a VOP, which is a very strange name, and I'm not actually sure what it means. I think it needs something like vector operator, which is not that helpful, honestly. What it is a program. It's essentially an informatic program, but node-based. So a lot like what we've been doing in Designer and what we're doing here in Houdini. So we're going to put down. Yeah, let's try and make a rock, okay? So we're going to put down a sphere first, okay? Looks fine. We have a sphere node here, and it's already. I want a polygon, okay? So here we have a polygon sphere, and let's give it a lot more subdivision. That's not enough. I want a lot of subdivision. Okay. So now we have a smooth sphere, which is better. No, actually, I want a lot more subdivision. That might be a bit too much, actually. Whatever. So now I have a sphere. But I want to make it into a rock, and it's not looking very rock-like for now, because it's a sphere, and rock do not look like sphere. So if you remember what we said about a procedure, it should be a way to create. If you imagine your rock, it should have like those sharp angles and faces. And obviously that's not at all what we have here. So we're going to want to make a procedure that allows us to get that. And in the classical node, you're not going to find that. So instead, we're going to use a VOP, an attribute VOP, okay? And let's dive in here. Because as you can see, the parameter space is very bare and nothing seems to happen. So you have to click here, and we are in this stuff. And already this is looking very complex and maybe a bit confusing. But what you have here is a lot of entries on your geometry. So I have the position of everything that's been fed here into this input. You have velocity, not useful here. You have color, you have normals, you have UVs, etc., etc. And here you have an output node, which will be what's going out of the node, and again, position, normals, color, etc., etc. So what you can do here inside is make modifications to the position, to the normals, etc. of your sphere by using nodes. And something that we could use and that could be fun is a noise generator. And we're going to use a unified noise static. So a noise is a random number generator, right? But let's take a look at what happened when... so we take the position here, and we put it here, the position of the noise, and we get a noise that we're going to apply as color. And nothing seems to happen. Very confusing. But of course, nothing is going to happen, because color is... well, it's a color, it's a 3D vector, but what we have here is a float. Right, it's just one number, so it's not going to work. So we need first to transform it into a float, into a vector. So we're going to use float2 vector. Okay. And now we have a float2 vector node, and now stuff should be beginning to happen. So let's do it like that to have level of gray. And now actually nothing is happening. How could that be so? Maybe it's just not strong enough. So let's put a multiply node. Okay, and make it a lot stronger. Still nothing. So that's a problem, of course, that you're going to encounter a lot, is that often things just will not work, and you are going to have to make effort to figure out why. But I'm not actually sure here. But of course the problem here is that I'm using a noise, and I'm not actually sure what is this noise. So in the parameters, what we can see is that we have a 3D input, and it's going to give a 1D noise, which I'm transforming into a vector and feeding into the color attribute, and it's not doing anything. I should be seeing color appear here. Maybe if I multiply like a lot. No, but perhaps there are a lot of zero values somewhere, and that's why. That's not encouraging. Maybe what I should use is a multiply add constant. That there are no zero values anymore. I'm not saying much. That's annoying. Okay. So we have a unified noise here, and you have the frequency of the noise. And what you want to do is use it to affect the position of your point. So what you're going to use is position translate. Well, let's just go back for a moment and see an attribute that I already made, and so that way I can use that to know what the fuck is going on. So as you can see, I have made a lot of those, because they are of course very useful. Okay. And if I feed the result of this into color, maybe I will actually see something. Maybe not. So of course, feeding things into color is not exactly what we're trying to do here. What we're trying to do is displace things. But when you're trying to displace something, you need first to know what is being displaced, and that's what the position is for, but you also need to know in what direction and with what strength. So direction is taken care here by displacement along normals, which is this node. So I'm feeding into it the position and an amount, which is determined by this noise generator here. And what that means is that if why is nothing happening? That's very frustrating. So let's use the displace along normals, and we will feed into it the position, and we will displace, and we use that as our new position. And now everything is gone, so at least something is happening. Displacement amount, more. Oh, now look at that, something is happening. Oh, he's not happy because he wants a position, and that's not what he's getting. Yeah, of course. This should go into amount, okay, and position should be P. Alright, and now we have a sphere, and it's actually deformed. Okay, that's great. And now you see how it is being deformed. And it is a very interesting shape, but not actually exactly what we want. That's not really looking very rock-like at the moment. Because no, we are not actually using the right noise. I wanted something more like a really cell-like noise. Oh, look at that now. Now it's looking a lot more like a face, like the faces of a rock, right? And it's it's very random too. So that's a better. But of course the angles are a bit too sharp and everything is a bit too straight. But we can modify that a bit. Let's make this noise a lot more fractal. Oh, better. Right, and maybe I want this a lot more rough. Okay, that's starting to look a lot more like a rock. And what did I do to get here? I use a noise, okay, and I feed it into a displacement, and now I'm displacing the position according to that noise. And I can get a lot of very varied result by changing what noise I use. So this will give me something a lot smoother. you can get a lot of very funky results. And that means that you are going to need to experiment a lot in order to find what you want. But you can get very strong and very interesting stuff by doing so. So VOP networks are going to be one of your most useful tools, but sometimes they are just, once again, they just do not have the nodes that you want or the nodes that you need, and they just do not do what you want it to do. So in that case, you are going to want to use the most versatile way to do stuff in Houdini, and that's wrangles. Attribute wrangles to be precise. So what is an attribute wrangles? Well, it's perhaps a scary thing, in that it is a line of code actually. Okay, so now that I have put down an attribute wrangle, what you see here is that I have a lot that I have a code snippet that I can run, and of course making up code on the spot is not a good idea. But you can of course do a lot of very varied things with a bit of code, right? So here, for example, I have a line, and I want to scatter point along this line. It would be great if I could see something, but I'm not sure what's happening here. But I do not get to choose where, right? So I must use a density attribute to decide where. So what I do is that I go here and I make a very short code, and that code allows me to use this ramp to decide the position of each point, right? Here I define this float that depends on the position of each, on the number of each point, and I attribute it a value based on that line, and that allows me to control through this parameter the density of point along that line. Something that I cannot actually do otherwise. So that's something that you're going to probably want to use when you're stuck. And when you do, you can end up with very complex trees like this that can give you very complex results. And that's something that will be useful if you're going to make a lot of different models based on that procedure, because otherwise, as you can see, it's not a great. It's going to take a lot of time to make this procedure. So that's something that you want to use only when you feel it is necessary. So okay, that's about that covers the tips and tricks of Houdini, and I think that gives you a good idea of what you can do with it and when you should actually try and use it. So now that leaves us a few minutes for questions. If somebody want to ask, does somebody have question? So I'm going to read the comments. Yes, please.
So is this more for terrain generation than asset modeling?
No, I mean actually you can model terrain with it. There are a lot of good tools, and actually, yeah, terrain is very often done procedurally, and it's one of the things that it's most useful, because you can run, for example, erosion procedurally, right? If I go back in Houdini, you have here 8 fields, which are the dataset Houdini used to deal with what you said, and you can have erosion based on a variety of factors. Like here, you can erode stuff based on water, based on heat. You can have heat erosion. So yeah, Houdini is actually very good for that. And of course, world generator that was talked about in the previous demonstration by Kettle, which is also, of course, a procedural generator. But as you can see, it can be used for a lot more things than just that.
All right, thank you.
You're welcome. Anyone else? And yeah, it takes a lot of practice, and a bit of the main problem that you're going to encounter, as I said, it's not very intuitive. So a lot of time to do something, you will need to know, you will need to find a trick, right? Like I showed here with the VOP, okay? That trick allows you to make a very nice and very rock-like shape. But of course, you have to know that there is a noisier called the Rolly Cellular for some reason that allows you to make these sort of things. And that is something that you're going to find with practice and with a lot of good tutorials on YouTube. And there are some. Any other question?
Ooh, if I could ask a question, how do you, or what's, I guess, the file that you export as, and I guess, I don't know, implement into, I don't know, the engine, the game engine? How do you guys get into game?
Yeah, that's a very good question. And the thing that I actually forgot to mention, and I should have, is that a lot of this stuff, well, it's going to make errors, right? So, for example, if I push here the displacement too much, you're going to see something very strange happen. Okay. And now things are going to things can collide into each other, right? If you move them too much, they're going to go past one another, and you're going to have inverted geometry. And so what you find is that a lot of time you're going to have to clean up stuff. Right, stuff is not going to be perfect because you do not have direct control over it. So what I do generally is I export into Blender. That way, in Blender, I can clean up stuff if it's necessary. Most of the time, you will want to make your procedure in a way that it's not necessary, but it can be. Okay, so what you get here is an output. But for some reason, this is not working. I have no idea. But okay, everything here is a model, right? Everything has a point and position. So every part of this here can be saved. Save geometry, and you can save it in a variety of format. So that can be FBX, that can be PLI, that can be OBJ. And but the problem is that with Apprentice, with the free license, you cannot export with FBX, so that leaves you mostly with OBJ or PLI. Does that answer your question?
Oh yeah, it does. Thank you very much. Though, if another question does naturally come up, does that mean if you were to put it into Blender, is there some like modifier on it? Say if you've exposed one of the parameters, if that's a thing that you can do to allow you to make some of those modifications in Blender.
Well, not directly, no.
Okay.
Well. In fact, what you would want here is an interface between Blender and Houdini. As far as I know, that does not exist. It does exist with other softwares. I think Maya has some stuff like that. And for example, if you're working in Unreal Engine, there are a lot of interface stuff built to interface between it and Houdini. But not, I'm afraid, not between Blender and Houdini.
Okay. Oh yeah, that's all right. Thank you very much. That's been very informative.
Yeah. Someone else? Well, I think that means that this is done. And so I'm going to leave my mic to leftover pad then. Thank you everyone, thank you for listening.